This will be the final video of this section, which took forever. We're now up to 5 videos, probably a total of about 45 minutes worth of instruction. I'm going to jump right into an example that probably should have went with the last one, but that last video was too long already, so I want to just see what we have here. It says S sub n equals 120. It says n equals 8. And it says a sub n equals 36. And this is another one of these problems that wants us to find the first 3 terms. So find the first 3 terms. As soon as I saw that S sub n, and I wrote that down first, I knew that I need that other formula. The S sub n equals n, and a sub 1 plus a sub n over 2. I need that formula. Plug in what you have. S sub n is 120, and this time they gave me is 8. Oh, I'm missing a sub 1. So I'm missing a sub 1, but it's going to be plus 36 over 2. Oh, I can find a sub 1 here. Distribute your 8 in to both pieces. This is going to be 120. When the 8 goes in here, that's going to be 8 a sub 1 over 2. It's over 2 also. So 8 over 2 is going to be 4. And so that will get me 4 a sub 1. The 8 times 36, let's figure out what that is real quick. 8 times 36 is 288, but then it has to divide by 2, and so I'm going to get 144. So plus 144. Let me say that again. 8 times 36 gave me 288, and then it has to divide by 2, so it's 144. Let's subtract 144 over, and I end up with 120 minus 144. That's going to get us negative 24 equals 4a sub 1. We divide by 4, and we get negative 6 is equal to a sub 1. Okay, I had to find the first 3 terms, so I now found the first term. All right, we'll see if you've figured this out by now. There's one thing I need, and if I have that one thing, I can generate all my other terms. That's the common difference, D. You're going to get it from the formula a sub n equals a sub 1 plus n minus 1, and there's D. A sub n, did it tell me in the problem? Yes, it did. It said it was 36. A sub 1, it didn't tell me, but I just found it. It was negative 6. The number of terms was 8 according to this, so it's 8 minus 1 times D. There, that's the missing piece. 36 equals negative 6 plus 7D. Add 6. That's going to be 42 equals 7D. I'll divide by 7, and I get 6 is equal to D. That is not the answer again. It's asking for what are the first 3 terms. A sub 1 was negative 6. The common difference is 6, so add 6 to that and you will get 0, and then 6. If you want me to keep going, it's 12 and 18 and 24 and 30, and you know what to do next. Okay, that ends that part of it. Now I'm going to show you some weird notation that we just need to know. It's called sigma notation. Sigma notation. Mathematicians at some point decided that they wanted a shorthand way to write the sum of a series like this. And so they did it with this. This is the Greek letter sigma. If you ever look at fraternity stuff, that's what this is. If you hear sigma, that's what they have. On top of this thing, they write the n, which is our number of terms. They write k equals some number at the bottom. And then they put some f of k, which would be like our formula, our you'll see what I show you here in a minute, of the way of generating these. And these are the pieces they'll have. The k at the bottom is a start. The n at the top is a finish. So it's kind of like telling you a sub 1 and a sub n in some ways. This over here is just the formula, the equation, the something. All right, I got 2 examples of this, and that should be all we would need, I hope. All right, here they are. Example 1, or example A, I guess, says find the sum of, it's 6k minus 1 from k equals 4 to 18. That's kind of how you would read that. The important part is the 6k minus 1. The bottom k equals 4 tells me where to start, and the 18 tells me where to stop. Well, okay, we need a formula. We're doing a sum, so that's S sub n equals n times a sub 1 plus a sub n over 2. Okay, finding the terms is relatively easy. A sub 1, that's a starting point. That's where you're going to use your 4. Take your 4 and plug it in here. A sub 1 is going to equal, which actually it's really a sub 4. But we're going to plug a 4 in there. We're going to do 6 times 4 minus 1. So our a sub 1, our starting point, is 24 minus 1, so it's 23. Our a sub n, our last term, is when we're going to plug an 18 in. So I'm just going to call it a sub n. And a sub n would be 6 times 18 and minus 1. That makes a sub n, let's see, 6 times 18 is 108, minus 1 is 107. Now I've found the a sub 1 and the a sub n. The only thing left to find is n, and then I can go back over here to the left and do my formula. The n is a little bit tricky, the number of terms. So n is equal to, well, let's see, if I started at 4 and I ended at 18, one of the easiest ways to do that is 18 minus 4. That would say that n is equal to 14. Except it's not really. When you take 18 minus 4, you're taking out the numbers 1, 2, 3, and 4. And so you're really only left with 5 through 18. But notice I wanted to start with 4. I wanted that included. So if I subtracted that out, I only have 14 terms. I need to add that first one back in, so n is really 15. Let me say that again. If it subtract 18 minus 4, you get 14, but that's canceling too many pieces out. Take the numbers 1 through 5, for example. If I went from 1 to 5, they are the numbers 1, 2, 3, 4, and 5. From 1 to 5, we know there are 5 numbers there, I hope. 1, 2, 3, 4, and 5. But if you do 5 minus 1, it takes the 1 out, and there's only 4 left. So we have to add that back in. I hope that makes sense. I'll do it again in the next problem. You just have to remember to add 1 back in. All right, plug in your numbers. This is the easy part. S sub n equals, I forgot my n already, it's 15. And 23 plus 107 over 2. And well, that's 15 times, let's see, 23 plus 107 is going to be 130. Divided by 2 is 65. S sub n is 65 times 15, and so we're going to add them up and get 975. So what they were able to tell me is find the sum of terms 4 through 18, not even the first one, it's 4 through 18, of this 6k minus 1 sequence, add them up, find the sum there, and it's 975. So I don't even have to add up all the numbers. I can find the partial sum. I can find parts of it. All right, let me do it one more time, and then we are done with this lesson. We are going to find the sum of, that's the way you'd read that, 5m plus 6, and it is from m equals 9 to 21. Okay, formula. Sigma, the sum one, S sub n equals n, a sub 1 plus a sub n over 2. Find your pieces. First term, a sub 1 we'll call it. It's really the 9th term. A sub 1, plug in 9 there. It's 5 times 9 plus 6. That's 45 plus 6, which will be 51. Got my first one. I find my a sub n, my last term. It's really the 21st term. Plug that 21 in. 5 times 21 plus 6. That's going to give us 5 times 21 is 105 plus 6 is 111. And then here's that tricky part that I did earlier. We're going to subtract for the n. N would be 21 minus 9, right? We started at 9, finished at 21. Subtract those out and you're going to get 12. Except what you did is you subtracted one too many out, add it back in, and your n is 13. Plug that stuff in. I shouldn't even need to help you with the end. Plug the 13 in and you're going to get this. S sub n equals 13. And 51 plus, wasn't it, 111 over 2. I would like to see a little bit of work here, so don't do it all at one time, but I don't care if you do 51 plus 111. That's 162. Divide it by 2. It's going to be 81. So I'd like to see this 13 times 81. And 81 times 13 is, the sum would be 1,053. All right, that finishes the lesson. You need to go into Canvas and check the next assignment, and so we will have a couple more problems added on, and hopefully we understand what's going on. All right.